In Section 4 of Chapter 1, we will be focusing on measurements. We all know how to measure things. We use rulers to measure length, scales to measure weight, and watches to measure time. Huh? What? You mean nobody has watches anymore? I should get a phone for that? Anyway, we all know about measurements, but what we might not know is just how important measurements are to science. In order to analyze something, we first need something to analyze. Those are the numbers. So everything we study in science is given a measurement. From this, we can study how it will act. But first we need to measure it. This is where we get the number. The more precisely and accurately we can measure something, the better we can understand it. Galileo said, "Measure what is measurable, and what is not measurable, make it measurable." What do you think he meant by that? Science is an international endeavor. We work across borders and languages to further our understanding of the physical world. A great example is the theory that led to the invention of the laser. It is called Bose-Einstein condensation. A German and an Indian physicist were able to work together to develop this theory. To make science work across borders and languages, we need a standard system of measurements. The system that we use is called the SI, Standard International, which was developed in France in the late 18th century. This standardization of units allows scientists around the world to clearly communicate their work with each other. Having a standard system of measurements is very important because without it, scientists would have to convert between different systems of measurements. The more conversions a person has to do, the more likely it is that he or she will make a mistake. For example, I know that 20 degrees Celsius is 68 degrees Fahrenheit, and that 0 degrees Celsius is 32 degrees Fahrenheit. But when I see a report that has a list like this, and I have to convert all of these to Celsius before I can even start to work, I am wasting my time. SI is scientific solidarity. Making science easier is just the beginning of the role that measurements play in our understanding of the universe. Have you ever wondered how we know exactly how far away a star is? Or how a radar gun knows the speed of a fastball or a passing car? How do we know the size of an atom when no one has ever actually seen one? Or even that one of the most difficult problems for scientists to answer is actually called the measurement problem. Taking good measurements is the first step in understanding these ideas, and in discovering ideas that we have yet to think of.